Everyone, myself Professor Bharat Kank, working as an technology evangelist at Tinkering Hub. On behalf of Tinkering Hub, we already started the Continuum, the road to implement Internet of Things in the real world. Now, in that particular event, we already planned the expert session as well as demonstration session. Okay, and on behalf of that, again, today we have expert session number 3, that is virtual hardware board design using different software tools for the different types of IoT application hardware board designing and development. And for this particular session, today we have Mr. Nishant Sonawala. Uh, Again, Nishant is working as an embedded developer, IoT developer since last more than 7 to 8 years of their experience is there. And one of the most thing is ki Nishant is again a part of our Parul University as well. Nishant has already completed their MTech, Masters of Embedded System Design from the Parul Institute of Technology itself. Okay. So again, today is a session which is proud for me as well. We invite our students as a guest, and they are deliver their expertise for our next upcoming the future techno trace as well. Okay, so the whatever the goal which we have, we need to create a different types of techno trade from the Parul Institute or Parul University. Okay, that fulfill. Okay, and now I would like to hand over the session to Nishant Bhai. Nishant will give some brief about their companies. Sonawala Integrated Circuit Limited. What is their main products? What are the products on which particular products they are working? There are different projects on that. Nishant is working. Okay. Then they will give some brief about the different products they already design, develop, and place into the market. And then he will guide us key if we need to design a simple any IoT based hardware board. So what are the different software tools we can use, how we can use that software tools, and with the help of software tools, how we can design, develop, and create a virtual hardware board. Okay. And once we have virtual hardware board, then that virtual hardware board is give for the fabrication, and final hardware board or IoT based any hardware board we can easily design, demonstrate, test, and then you can use for that particular IoT application over here. So now I would like to invite Nishant by here. Nishant, can you please begin the session? Yes.
Yes, thank you so much, Bharat sir. Uh, as being a part of Parul University, it's been a great pleasure to be here and serving you as the guide for the IoT board development. So, first of all, let me introduce myself. This is Nishant Sonawala. I'm currently working as embedded developer as well as software developer at Sonawala Integrated Circuit Industries Private Limited. I've been working in IoT field since last 5 to 6 years, and I have been in this embedded field since 2013. I have been in embedded field. So first of all, let me introduce my company. So Sonawala Integrated Circuit basically divided into two parts. The first department is IT department. So our IT department works for the different MNC companies. We are providing solutions, websites, softwares, applications, iOS applications, and customized softwares. So the basic clients for our IT departments are Amul Dairy, GSRTC, HPCL, then Orpec, Super Aliens, Tajin Tech. These are our clients for which we are providing a solutions. And apart from IT, the main area of interest, which is electronics, embedded system. So in IT, apart from IT, in embedded system, we are providing solutions to medical industries, chemical industries. Then we are providing solutions to customized electronics developments. We are providing solutions. Basically, since last 3 years, we are providing medical grade designing. We are designing a products which is suitable for medical use. Customized medical designing we are using. One more thing. Yes, someone has any doubt, Bharat sir? Okay. So basically today I'm not taking too much time to introduce my company. Simply I just give you a brief introduction about this company. Now I'll show you that what kind of products we are developing in industry. We have designed many industrial IoT based products which is called as Industry 4.0. So give you some of the brief outs. So these are the products we are actually designing. Such kind of PCBs we are designing. I will show you different PCBs. This is industry grade PCBs. This PCB is dedicatedly designed to get the data from the solar systems and providing to the end. Means we have implemented the whole system into Surat. It's a government project, and we have supplied this module, and we are monitoring as well as controlling the panel data, and we are providing a monitoring system with this device. We have different lot more devices. This is a development board we are providing in the market for the application specific design. So this is again we have designed dedicated for the education purpose. For IoT education, this is our medical grade device. It is working for the ICU patients and transferring the whole data over the internet to monitor and track. So this kind of work actually we are doing at Sonawala Integrated Circuit Industries. One more thing, I just want to tell you a few things about how IoT works and in which field IoT actually utilized. So in medical industries, chemical industries, then mechanical industries, IT, stock markets. Yes, in stock market also IoT is the most what can I say, is a favorable technology in stock markets they are using. Then research and development, machine learning and artificial intelligence, right? So today's our main topic is to see how we can design a board, hardware board, right? PCB design हम कैसे कर सकते हैं? How to design a PCB which is compatible for IoT device. So basic thing, there are many tools available in the market, right? Like we have orcad capture, CIS orcad tool, then Altium, Eagle. So professionally, I can say that in professional avenue, we can see that Altium is used as professional development. But for education purpose, we can start with the orcad. So today I am going to show you the orcad, how we can design in orcad, and then we'll switch to the Altium. So I can see you that how exactly the prototype of any IoT board looks like, right? So before designing of PCB, first of all, I need to tell you a few things you have to consider in mind. First thing, that before designing a PCB or before designing a IoT board, you need to require the component details as well as what kind of device you are going to make, right? So for that, what you need a schematic or a test circuit, right? First of all, you need a test circuit. Aapko kya bana hai, what you want to design, that you need to first understand. So I can say, like, as on screen it shows that I have put one ESP12EE, means ESP8266 board, right? And simple, I have created a simple circuit. It's a bootloader circuit to upload a program into the ESP board. Okay, ESP board actually we are using on education purpose to create some IoT based or IoT enabled devices, right? So for education purpose, ESP is the most useful device we are using. So now today we are seeing that how we can use ESP8266 as the IoT board designing. So IoT board designing requires few things. First of all, you need to identify that what kind of application you are looking for, that application, which controller you wanted, right? Memory of that controller is also required. One more thing, IoT means it is enabled over the internet, but not only enabled over the internet, you need to see that whether the protocol, Wi-Fi protocol, is capable enough to handle the application traffic or the data streaming, right? You need to first consider that. After that consideration, you have to select your own controller. Today we are seeing that ESP12 we are using. right? So let's start with the board designing. First of all, what you need to do, you have to create a schematic. It looks on our screen that you have to create schematic like this. Okay, now we'll start with schematic designing. First of all, we'll take one new project. So let me introduce first. This is a orcad capture CIS. It's an orcad software. It's a design entry orcad capture. Okay, so it's an orcad software. So you have to create a schematic, your netlist, your footprint, your PCB board, everything. For that, orcad is best tool as an open source to start with the PCB designing. Okay, so now let's start with the designing portion. First of all, I'll show you how you can create the first schematic. So first of all, you have to go to file, then go to new project. Here in project, you have to mention your PCB name. So now let's design our test PCB. We are creating a test PCB. Simply select the schematic and select OK. As you select OK, it gives you like this screen. Okay, so first you have to open the page, and that page will looks like this. So before starting a schematic, you need to mention a title of your project. This is the best practice you have to perform while designing a PCB. So here we mention test PCB. Select OK. Document number. Document number you can give any if you have. We are giving document as 170721-SICI-test design. Okay. Now revision code. First, what is revision code? So when you design a schematic, right, you have to start with revision code 0. Why? Because you have no idea that what are the changes made after you creating. Okay, so जब आप क्रिएट करते हो आपकी स्कीमेटिक और उसके अंदर चेंजेस आते हैं आपको, देन यू हैव टू मेंटेन योर रिवीजन like 1 2 3 4 5 6 so that you can identify that how much time you have updated your schematic. So we'll start with 0. Now let's start with the designing. So how you can pick your component? So you can see here above you will find a tool. I'll give you, let's show you. See, this is the tool. You can see, right? Based upon this tool, you can choose the placement of component. Place part P. As you can see, my cursor is moving around the place part C. You can go with go from here, as well as you can go to place and select the part. Once you select the part, you will see the screen on my right hand side. I'll show you one more time. Part. As you can see, I can see the part on right hand side. Okay, now you have to choose the component. Suppose we required a component like resistor, so simply you have to type the resistor. When you type the resistor, you can find the different types of resistors are available. The footprint as well as the packet size, you can see different resistors. So what kind of resistor we require? We require a simple resistor. Put that resistor, double click on resistor and give its value. Select the component. If you want to rotate it, simply press R and you will rotate that particular component. Okay, now let's make one LED blinking PCB. So for that we require one more LED resistor value will be 330 ohm. So whenever you want to mention ohm, you have to simply write the E. Okay, now let's just connect. Okay, this is one thing that I want to mention, that this is not a simulator, right? It's a actually PCB designing tool. It's not a simulator. So we have to mention here a particular part number. I'll show you what I want to convey. See, we required here connector con 2 pin connector we required. As you all have seen that on PCB, you won't find the battery positive and negative, right? You have to plug in that particular pin inside the hole of a battery positive and battery negative, right? So for that we required one particular junction or particular jumper connector where we can connect our batteries positive and negative terminal. Here we cannot take the battery, physical battery, and show you, right? So let's consider that the one number is our battery VCC. So connect it with and the ground, right? So simply we have created our one schematic for LED, right? So once you power up, it directly gives you the power. Okay, what we want to do, we want to put one switch over there so that we can turn on the switch and turn off the switch, right? So let's simply take this switch. So we will choose the switch, 2-pin switch. There are different switches it shows to us. We'll choose switch which has only 2 poles. We are choosing this switch and name it as on and off switch. Okay, now connect it as I do. Okay, once you have connected this, it means that battery is connected with your circuit. Now whenever you put the switch on, your LED will start, switch off, LED will stop. Okay, so this is how you can create actual circuit for your schematic or for your circuit, right? Okay, one more thing, that is it looks अगर हम इसको देखें, it looks little bit ugly, right? So what we want to do, if we want to create it in a proper way, so we can do it another way. Do not connect like this. Make every component independent. Okay, only connect these things and make an off-page connector. Of what off-page connector does, so this off-page connector is work as wire, internal wire. We can choose here as a GND. So we have mentioned the name, right? GND. Now we have to connect this GND with our switch. So automatically our system considered that this ground pin is connected with the switch part 2, right? Okay, the same way we are going to connect VCC. So we are providing VCC here. The same way we have to take the off-page connector and connect that to here. Okay, this is how we have connected our VCC 1 number to the resistor 1 number pin. Okay, now remaining one connection, that switch 1 number and connector 2 number, that we have to connect. So this con 2 is actually our battery. So battery's negative portion we have to connect. So what we do, we can do it. We can name it as con 2. The same name we have to apply on the source side, con 2. So con 2 and con 2, if you give the same name to the same component listing, it will automatically connect with each other. Suppose this is con 2 and this is con 2, so it is internally connected. This is ground, this is GND, so it is internally connected. If I write here VCC, it means VCC is directly connected over here, and this ground pin is not connected with second number pin. It connects with VCC directly. Okay, so whenever you design, you have to keep in mind that whatever off-page connector and whatever the notation whatever the NAT you are using, that you have to mention here, right? And you have to keep in mind that do not connect different NATs with your component. Otherwise, you will create the bug. We'll change to GND. So this is how we can create the schematic. One more thing, what if we don't have the part in our what can I say, in our library, right? So how we can add that particular part into our library? So let's see that how we can create a part from the library. Let's take this ESP. We need to create this ESP. So let's see first that we have ESP or not. No, we don't have ESP in our library. We need to create this ESP library in our ORCAD. So how we can create? So first of all, we need to go to file, then go to project, new, and then choose the library. When you choose the library, you will find here that library gives you the OLB file. So click on right click, then click on new part from spreadsheet. Okay, new part from spreadsheet gives you the idea that what kind of pins you need to define. So we have to mention our pins. Before mentioning the pin, we have to mention the part name. So let's assign the part name. Part name as ESP12E. Okay, okay. Number of sections. So what is number of sections? So number of sections means we have only one sections. So on top side, we can see directly on top side that we have only this much pin. It does not contain the bottom pins, right? Top pin as well as bottom pin. Okay, if you have the top pin as well as bottom pin, means you have two sections. First section is on above side, top side, and another section is on bottom side. But in this particular scenario, we have only section 1. Okay, part prefix. What is part prefix? So generally, if we design any IC or particular what can we say, particular part, if we design, suppose if we design resistor, so its part prefix will be R. If we design capacitor, so its part prefix will be C. If we design inductor, so its prefix will be L, right? So as we are designing a particular circuit, we are designing a full circuit, right? So we are mentioning its part prefix as U. Okay, now let's start with the design. So before designing this, we require the components part numbering. So 1 number, 2 number, 3 number, 4 number, 5 number. So we have to mention first. Before mentioning that, let me show you one thing, that on left hand side you have few pins, bottom side you have few pins, and on your right hand side you have few pins, right? So first of all, we have to naming like 1 2 3 4 5 6 7 8. 8 on left hand side, 9 10 11 12 13 14. 6 on bottom, so 9 10 11 12 13 and 14. Okay, now we have on other right hand side, we have another 8 pins, but we are not defining as 15 16 17. We will start with 22 21 20 19 18 17 16 and then 15. Why? Because as we can see, RST to VCC, it is 1 to 8, right? CS0 to SCLK, okay, it is 9 to 14. Okay, so what will be the 15? So 15 will be GND, right? And if we design here as 15, so it will take it 15 as TXD. So we have to mention from upper to lower. So 22 21 20 19 18 17 16 and then 15. Now we have to naming all the parts. RST ADC enable, then GP16, then GP14, 12 and 13, GP12, GP13, then VCC. Okay, what is 9 number? CSO, then MISO, MISO pin, then GP9, GP9, GP10, then MOSI, MOSI, SCLK. Then okay, now here we have to mention the 22 number of pin. So what is the 22nd pin of this ESP? So we can see that 22 number is TXD, not GND. GND is 15. So we are writing TXD on 22nd pin. Then RXD, GP5, GP4, GP0, GP2, GP15, and then ground. Okay. Okay. Now type of that pin. So RST, it's a reset pin. So we can say that reset pin can be work as bidirectional, right? ADC bidirectional. Okay, now VCC, it's a power pin. So we have to mention the power pin. It's a power, then again bidirectional. All the pins will be work as bidirectional. Ground pin, it's a power pin. So again, it's a power, right? Now we have to give this shape to our pins. So we are providing a shape. There are different shapes available. Clock shape, dot shape, line shape, short dot, short. We are choosing the standard line shape to every pin. Okay. After that, we have to mention the position. So as we all know that from 1 to 8, we have to make it on left hand side. So we are providing on left. Right, from 9 to 14, CS0 to SCLK, we have to mention it on 9 to 14 on bottom side. So we are choosing on bottom side, and from 15 to 22 on right hand side. Okay. As we have mentioned only a single section, so the section will be common for all the pins we have mentioned. Okay, so a library is almost created. We have to save that library, ESP12E. Now go to your page and inside your part search for ESP-12. See, you can see our library is created for ESP, right? So the same we have created. This is the ESP, this is the ESP we have created. Okay, this is how you can create your own library. Now if you want to make some connections with it, you can use the WS wire, you can connect anything with, and this is how you can create the library. Okay, so I have already prepared, because due to time constraint, I have already prepared a schematic. So first of all, I'll show you that what is the schematic is all about. So ESP is a controller, Wi-Fi controller we can use for IoT application, right? We can integrate different sensors with it, and we can get the data all over the globe with the use of internet. And there are different protocols available in the market. We can utilize that protocol to program our ESP. Like we can go with the MQTT, then constraint application protocol, then AMQP, advanced message queuing protocol. These are the IoT protocols. So we can integrate with our program and make an application. So before designing a program, suppose you have created a program, so how you can install that program into your ESP? So for that you require a bootloader circuit, right? So this ESP controller or ESP module requires a bootloader circuit. So I have created a bootloader circuit for this ESP12. Okay, so we have the reset, we have the flash. Okay, how many resistors we have? So 1, 2, 3, 4, 5, and 6. 6 resistors we have. 1, 2, 3 capacitors we have mentioned. Then we have the 2 probes. this power probe and this RX-TX probe. Okay, so inside this circuit or inside this module, you don't have the RX pin or TX pin where you can actually serially transmit your data, or serially you can get your data. Okay, so we have created a RX and TX pin, RX and TX, right? So that you can connect it with other devices, or you can connect with other controllers for serial communication, right? In IoT, serial communication is a common practice, right? That you can get the data from your IoT device, and you can transfer that data over the serial communication over the RS485. It's a Modbus over a Modbus communication, or I2C, wherever you want to get the data from the sensors, or you want to transmit the data over the serial, you require the RX pin and TX pin. Okay. Okay, so we have created a RX-TX pin. Then we have created a VCC and ground. As I have shown you that that jumper, right? So 2-pin connector. First of all, I will show you what exactly that 2-pin connector jumper is. So jumper connector simply looks like this. Okay, everyone has used this kind of jumper wires, jumper pins, right? So we have mentioned the footprint for this particular jumper pins. We have mentioned the footprint for 2 pins, not the whole 16 pin, but the 2 pins. Only for 2 pins we have created this J1 and J2, right? So at the end, when we actually practically implemented this, you can easily understand that how we have implemented this J1 and J2. So, okay, so this is the first step you have to define before designing a PCB, that schematic should be ready, right? All the components should be ready. Before designing this thing, you have to mention, or you have to prepare things like you require the controller. Okay, so you have to choose that what exactly the size of controller you require, what are the through hole components you required on your PCB, what are the SMD components you required on your PCB. Okay, that you have to bifurcate before designing a schematic. These are the process. Okay, so today we are going with the through hole components. We have mentioned, we have defined the footprints to every resistor and capacitor as a through hole. Okay, so we have given the footprints to every, I'll show you that what exactly the footprints looks like. So ESP resistor, here we have given the ESP resistors. I'll show you that what exactly the footprint is all about for resistor. Open ESP resistor. Okay, so ESP resistor, this is the footprint we have assigned to that particular schematic. So here, how we can create this footprint, I'll show you how you can create. So first of all, you have to start the PCB editor. PCB editor, then you have to go to Allegro PCB design GXL legacy. Once you start this, you will find screen like this. Now go to new and write down your ESP resistor test. Suppose we are designing this kind of resistor and we are giving a test name to it. Now enter. You will find this blank screen. So before designing a footprint, you required to set up few parameters. Go to display, color visibility, select the package geometry and assign the silk screen top and bottom to yellow. Then simply apply OK. Then go to setup file and use the user preferences. Now inside user preferences, you have to select the path. In the path, you have to go to library and you have to check that where is your pad actually you have placed. Okay, so we have already given the path, that test PCB design inside the G drive. Okay, now simply apply and OK. Okay, now we have to go to setup, design parameters and allow the grids on, apply and then OK. Okay, so here we have our origin. This is our origin. Okay, now what we have to do, we have to create a resistor footprint. Okay, so resistor, for creating a resistor footprint, first of all we require the dimension for that resistor. Through hole resistor footprint we required. So let's see that what are the exact footprint we required. Okay, so here we have the reference. Okay, now we are designing the footprint for resistor. So here we have already mentioned, here we have given the 5 mm of distance. Okay, 5 mm of distance. This whole software is working in mils. So first of all we are converting that 5 mm to mils. Okay, it's a 196 mils. So let's go to the PCB editor, and we have to choose first of all our pin, which pin we are going to use. So we are using the LED pin. It's a round circle pin. Okay, now I'll show you putting on a random side. See, this is the two dots which you are actually seeing on PCB, right? That you have to put your resistor inside, resistor pin inside your this two leg, right? So we have to create, this is called a footprint. So first of all we have to create a proper distance between two pins we are mentioning. So we are actually cancelling it. Now we are placing a distance between these two is 196. So we can calculate as 1 on 196 divided by 2, we can have the 98. So we can place that 98, spacing will be of on x-axis v 196. Okay, now we are writing here x minus 98 comma y 0. Okay, what is x minus 98? X minus 98 means there is a 4 quadrant and our pad will be placed on x-axis only, not on y-axis. So simply enter it. Oh, first of all we have to select our package, then 196. Now again write the x minus x minus 98 comma y 0 and enter. Okay, only one point we are getting. Why? Because we have done only one part selection. So what we have to do, first of all we have to go to select a pin, pad stack, choose our pad, and then mention quantity as 2 pins are required. So mention the quantity as 2. Okay, now again write x minus 98 comma y 0 and enter. You will find the distance between these two pin is exact 198. So let's measure it from this point to this point. Okay, we are getting the distance of 196. Total distance is 196 mils, which we have already calculated, 196, or you can have the 197, right? Okay, what is the next step? So the next step is to place, I'll show you a random thing. You have to place this square box in between, so that you can identify that your resistor will be go outside, your resistor will be go over this, right? So you can save as done, but this is not the way we have to do. I'll forgot to show you. Okay, you have to choose your box, then go to option, then here you have to choose the package geometry, right? And package keep out. So first of all we are designing a footprint. So for footprint designing we are taking package keep out, and this package keep out we are mentioning over here. So package keep out. distance we find 196. Okay, clarify. And package. Okay, package keep out, we have to package keep out, choose package keep out, then stitch grid is none. Okay, now we have to design our okay. So this is the final lookout. Okay, so this is how we have to create the package keep out board. Then simply make copy of it and paste on other side. Oops, and done. Okay, so this is how we have created the footprint. Okay, it shows us the error that symbol is missing. As I said previously, that if this is a resistor, then we have to mention that prefix for resistor. So prefix for resistor is nothing but R, so we have to mention here R and then question mark, right? Okay, save. Now we have to see that what is the first number pin is on our board. So for that we require the silk screen top of this one number. So click on right click on one number, make a copy of it and place it over here. Done. And then click on right click, change subclass package geometry and make it as a silk screen top. This is how we have created our first footprint for our resistor. This is a resistor footprint we have created. Okay, this is how we have created a footprint, and that footprint name is ESP resistor underscore test. Okay, we have already mentioned all the footprints to our schematics. Okay, select the all the schematics, click on right and then edit properties. I'll show you that I have already mentioned all the footprints. Right, this is the PCB footprint we have assigned to all our components. For capacitor we have the ESP capacitors, for J1 and J2 we have the ESP count, for resistor we have the ESP resistor, for switch we have ESP switch, and for U1 we have the ESP. Okay, now simply save it. Okay, okay, so this is how we have created our own schematic. Right, now what we have to do, we have to create a netlist. Okay, so in PCB we have the PCB design, right? That software understand the netlist, that which are the points we have connected this one number with this line. Okay, so this line goes to the one number of J1. So system understand that U1 one number is directly connected with J1 one number. Okay, so netlist will be created accordingly. So what we have to do, we have to go to our project. Inside that project, go to the option okay, go to tools, and here you can create a netlist. Click on the create netlist, and here you will find that you have to store a netlist somewhere. This netlist will allow us to design a PCB. Okay, so let's create a netlist first. Okay, okay, so netlist is already created, right? So here if you can see that they have already mentioned that cap 10 microfarad a capacitor, one number pin is connected with one number of pin use, right? This is how the netlist creates. Okay, now let's design a board. So designing a board, we have to go again into PCB Allegro. I'll start again and show you that. Go to PCB Editor. Inside this PCB Editor, select the Allegro PCB Design GXL. Here we have to go to file, then select new. Now we are designing a board, so we have to select a board and we have to mention the board name. So we are giving board name as test ESP-PCB. Okay. So again, we got the blank page. Again, we have to do the same steps. Go to display, color visibility. Now here we have the package geometry. Allow silk screen top and bottom to yellow. If we want to masking our PCB to a blue, then select the blue color and allow it to solder mask bottom and solder mask top. Now apply it and OK. Go to setup, design parameters, allow the grids. Okay. Again, go to setup and change the drawing origin. Okay. Now, before importing the netlist, we need to define the area, in which area we want to design our circuit. So we have to mention our area first. So we are defining our area of PCB. So this is a random area we have defined, and inside this packet board geometry, we are actually drawing the PCB. So now importing, go to file, import and logic. Okay, now we have to mention here the netlist. So new test will be our netlist. Import. Now import to cadence. We have imported a component successfully, but where is it? Okay. So wrong placements. Go to import, again go to logic. Here we have to mention a directory. So directory and then import. Once you done with the import, you will find that components were placed around the board geometry. See, these are the components we have defined, and we need to enter these all components into our PCB. Where is that? Import logic. Okay, importing is done. Now we have to quick place all the components, place and then OK. So we have now all our components on our board. Now we can delete it, and according to our design we can have our own board. We can manually place each component. Wherever we want to put our components, we can place it like this. Okay, now I'll simply show you. Suppose if we have placed our components like this, and our PCB size will be like smaller than this board. So delete this board and make this size according to the board. Okay, now what we have to do, simply we have to select our board and go to root and PCB routing. Okay, so we are doing the auto root automatically. Okay, now grid will be 0.5. Offset we don't require. Again, bias grid is required, so bias grid will be of 0.3, and start the routing. Once we have completed the routing portion has already seen that our component is internally connected. Okay, now still if you see that the PCB size is bigger than this, then simply make it smaller. Okay, so this is how we have created our PCB. Now it is time for etching. So let's go to option, choose the, and first of all we will etch on top, each on top side. So we have to select the area on which we have to start etching. Okay, so this is our top side etching. Now we have to apply on bottom side. So now it is time for bottom side. So we are placing etching on the bottom side the same way we have done. Okay, so top and bottom etching has already been successfully implemented. The next thing we are going to implement is defining the board geometry. Board geometry that allow we are designing board geometry. Okay, so we have mentioned our board geometry and save it. So we have successfully completed our PCB. Now if we want to see that how our PCB actually looks like, we can see it in 3D view also. Okay, so the bottom connection of our PCB will be look like this. So this is cadence, orcad cadence. It's a basically we have implemented resistors and capacitors and switches, right? It does not contain the library of actual component, right? So we can use this cadence as the only educational purpose. We don't see the exact component library, right? But we have created this top and bottom. We have created a PCB, right? Connection PCB. Now I'll show you that what exactly happens or how exactly the PCB looks like. So this is how we have created the schematics over here. Okay, I have already created a schematic for my IoT device. We have connected with pedometer sections. We have connected ECG sensors, temperature sensors, and there is a controller. Okay, it's an IoT device for medical use. Okay, so what we do after creating a schematic, same thing we require as a netlist, and netlist create this out job file. Inside this orcad file we are getting the netlist as .dat file. As you can see, .dat file. Different software have the different file formats. Okay, so this is the file format of out job. This is the file format for the netlist we have created in Altium. Okay, and after creating this, we are designing the actual PCB, which is look like this. Okay, after routing, the same way we have designed a PCB which is look like same way. Okay, जैसे हमने यहाँ पे डिजाइन किया, ठीक वैसे ही we have designed over here. This looks amazing in because we have the part library as well as the part detailing. Okay, in orcad we don't have the part detailing because we have manually created all the parts, right? Okay, so how exactly this look like? So these are the different pins we have manually placed. This is our controller. So this is controller's bottom section we have already manually placed. See, the bottom layer looks like this. We have implemented different netlist. This is the 4-layer PCB we have created. Okay, now how exactly looks in 3D, that I will show you. First of all, you have to choose your circuit and go to in 3D. This is actually look like this. Once you have completed, you will find that your PCB will be looks something like this, right? So this is how we are designing at Sonawala integrated circuit. We are designing PCBs. We are designing a particular customized products for our clients. So a few more designs I want to show you. That this is the basic and this is the standard format Okay, this is an industrial IoT first device. We have implemented the same device for the SMC project. SMC have implemented the panels which generates the power of 11 megawatts, right? And we have implemented our Vari panel system over there, and we have installed our this device. We have installed this device on that Vari platform, and we are monitoring, capturing, as well as controlling the parameters for that particular solar system. One more thing, the same device we have utilized, the same device we have implemented for industrial IoT for controlling a variable frequency drive, wireless variable frequency drive. Actual device, I can show you that how exactly this looks like. We have uploaded video for that device, wireless variable frequency drive. So this is the, see, this is the variable frequency drive, and you can see that this is the circuit. This is the actual circuit we have implemented.
Full screen करना थोड़ा full screen. Make it full screen.
Okay.
Yes. Now
So
it is.
this is the actual device we have implemented and successfully installed. Okay, so which is this device? So this device is already, I have shown you over here that this is the same device we have implemented, and the application we have already posted on YouTube, that how this actually device is working. So in my office, I have made a setup for this PCB. And see, with the use of Internet of Things, we can create, we can monitor, as well as we can control the VFDs. This is how we can control all the industrial data.
Full screen. Can you please make it full screen?
Yes.
YouTube video. Okay. And okay, now you can continue.
Yes. See, I'll show you one thing, that we have created our own application, and with that application, we are controlling the VFD. In real-time scenarios, VFD will be worked. So this is, we have already implemented in different industries, and we have taken the trials. This is L&T SX2000 series VFD, sorry, CX2000 series VFD we have implemented. We have already tried it on ABB, Yokogawa, Yaskawa, Delta. We have already tried and we have tested. So this is how we are creating an IoT based board. This is a sample design I have shown you, that you can utilize it for your design aspects for IoT applications. There are many applications of IoT available in the market, or you can expand beyond your thinking what IoT can actually do. So for that thing, if you want to design your IoT board, this is the process, and this is the tools I have shown you. You can utilize and you can design your own IoT devices using these tools, as well as you can design the embedded based any product using these tools. If you have any doubts, or if you want to learn more about it, you can contact Bharat sir, as well as you can directly contact to us on Sonawala Integrated Circuit Industries Private Limited. We are providing you the details regarding that also.
Okay. Thank you, Nishant Bhai, for giving such a valuable knowledge on the how to design different types of IoT based hardware board. Okay, and how we can use that hardware board for different industrial application as well. And if any student or any learner want to start their own PCB development board, okay, so they can start with the orcad cadence tools. Okay, and now for the viewers, those who are interested for the designing, development, and testing of different types of IoT based hardware boards, okay, at Tinkering Hub again will come up with the hands-on workshop as well. Okay, and if anybody having any doubt, query, question, you can ask us through your chat box as well. Okay, and I already posted one feedback link for the particular today's session, as well as the one quiz. Okay, So student or the learners, those who are required to get the certificate, they need to fulfill this registration form and feedback form as well. And okay, so with this help, we'll conclude the session. Again, I'm thankful for the Nishant bhai for giving such a 1 hour time from their valuable time as well. Okay, yes.
Thank you so much, sir. For Palwit University, anytime Nishant is available, sir.
Okay, thank you, Nishant bhai. It is our pleasure that you are always ready to give expert lecture, or you are ready to share your knowledge for the student as well. Okay,
Thank
yes,
you so much, sir.
yeah, thank you.
Can I leave the meeting, sir?
Yes, you can leave now.
Okay, thank you so much.
Yeah.